Okay, we're moving right along. There will be some overlap in what we've talked about in the previous lesson, but we're going to add to our list of those functions that we call parent functions. So far, we know y equals x squared, and y equals the absolute value of x. And we've talked about how to translate and transform those parents. We have certain rules that we've been looking at. And so we're just going to add to that list with the square root parent, and then how do these transformation rules apply to that parent as well. But to begin with, the first part of your lesson will involve identifying the domain and range for these square root functions. And here's the gist, okay? To avoid being a non-real number, or in other words, to avoid trying to graph something that is imaginary, the number underneath the radical has to be either 0 or greater than 0. That makes sense because, for example, if I let x be 0 in this first function, I'm going to get the square root of -3. And that's not real. That's impossible to plot on the real number plane, which is what we're going to be working with. So to find the domain, I'm looking for a number for x that causes this to happen. Whatever x is, it has to make whatever's under the radical either 0 or greater than 0. So to find the domain, just take whatever's underneath the radical and do this little inequality, and that makes it pretty obvious as to what the domain should be. All x such that x is greater than or equal to -3. Or using our interval notation, we would say from -3 to +3. Yeah. Thank you. Y'all are looking at me weird, and I'm thinking, what's going on? Yeah, I don't know why it said -3. So all numbers 3 and bigger, we would say in interval notation from 3 to +infinity. For the range, we're going to take this result that we got for the domain, and we're going to evaluate the function. So it's like we're going to do f of 3. And evaluating this function using input 3 literally says this. You just replace x with whatever your domain value was in the inequality, and we get 0. Okay, so let me give you a little sneak peek about what this is going to look like when it's graphed, and that'll help you understand how to interpret the range. This graph, and you're going to see this in more detail in the next slides, this graph is like a curved ray. Remember a ray in geometry has a definite endpoint and then it shoots out from that endpoint? Well, these guys are like that. They have a definite endpoint, but they curve as they go either left or right. So remember, if there is a positive in front, then that means if that were a parabola, that means the parabola would open up. Well, the same is kind of true here. If it's positive in front of the radical, the curved ray is going to go up. So that helps me understand how to interpret the range. It's going to be from 0, that's kind of like the bottom limit, and then it's going to continue to go up along the y from 0. So to finalize my range, I'm going to say all y from 0 to +infinity. If it had been this, negative, that means this graph would be from this endpoint heading downward. And now I'm talking about all the numbers less than or equal to 0. Okay, does that make sense? All right, so let's talk about letter B. First of all, we're going to identify the domain. So again, just take the part that's under the radical. That's what we care about. We've got to make sure that this represents a real number. So just set up a little inequality that says x plus 6 is greater than or equal to 0. I'll make sure I can do it right this time. So now we're talking about all of the x's that are greater than or equal to negative 6. And in interval notation, that would be from negative 6 to positive infinity. To find the range, take your value that you got in your domain inequality and just plug that in, evaluate the function using that number. Let's find f of negative 6. Well, if you do f of negative 6, that's going to be the square root of 0, which is 0, and 0 plus 2 is 2. Once again, since it's positive in front of the radical, we're going to have this basic shape. So 2 is actually going to be, you can think of it as the very bottom of the range, and then it's going to continue to go up from there. So the range we would state as all the numbers greater than or equal to 2. Or in interval notation, it would be from 2 to positive infinity.
So now you don't have negative infinity?
Not in this case. Now, if it had gone this way, then we would. Now it's going down. So we'll take a look at those. Letter C. To find the domain, once again, just take the part that's underneath the radical, make it greater than or equal to 0. So the domain is going to be all x that are from 0 and bigger. And once again, just getting used to seeing interval notation. There's the domain. Okay, so here is kind of what Johnny was talking about. With the negative, here's going to be the basic shape of the graph. Now it's going to dip, and it's going to continue to go downward forever. So when we evaluate this function, in this case we're going to do f of 0, what do we get? We get 1. So now you can think of 1 being the top of the range. And the graph is just going to continue to go downward from there forever. So what would that look like in interval notation? Negative infinity. Always put the smaller on the left to 1. Okay, real fast. Letter D, if we want to find the domain, just solve this little inequality, x minus 5 greater than or equal to 0. So all x greater than or equal to 5. Here's the interval notation. To find the range, evaluate the function f of 5. 5 minus 5 is 0. We're going to get negative 3. And once again, with the negative in front, we're looking at this kind of graph. So negative 3 is really going to be at the very top, and the graph's just going to continue to go down from there. So what does that look like for the range interval notation? Okay, everybody good on domain range with the square root function? Now let's get into what's the graph look like. What is this specific parent function we call the square root function? What does it look like? And then how do we transform it? Well, the square root function, there's really 4 points that you can always use to identify the parent. And just think about numbers. First of all, we can't use anything less than 0, no negatives. Let's start with 0. The square root of 0 is just 0. And then let's just think about, for easy math's sake, numbers that have perfect square roots, like 1. The square root of 1 is 1. If I input 4, square root of 4 is 2. And then if I input 9, the square root of 9 is 3. So those 4 points are the ones that I use to identify. Obviously there are many, many more, but those 4 points can be used to draw what we call the parent function, y equals the square root of x. And it's from this parent that we get children, child graphs. Okay, so let me just rehearse with you what the transformation rules look like. You've already seen them with x squared, square root of x. They're all still in play. It's just that it looks a little different because we've got the square root. So this number, I'll just start with a. This is either going to give us, if a is negative, that's what's going to give us the flip. We just talked about that a minute ago. If a is greater than 1, then we're going to have stretch. It's going to take our parent and make it do more like this. It's going to make it either, if it's a negative, then it's going to make it extend further negative, downward. If this is a fraction a, then that's called compression, and it's going to take the parent, which does something like this, and make it closer to the x-axis. It's going to squish it. Okay? So the number greater than 1 extends it, and if it's a fraction, that's called compression, and that makes it come a little closer to the x-axis. We're already familiar with h. H stands for horizontal movement, which means left or right. And you got to be careful because I'll just give you a real quick example. If you have this, how am I moving? I'm going 2 to the right because h is the number that tells you how to move, and h is literally positive 2. So let h tell you to move either left or right. If it were plus here, then that means h must be negative 2. Negative is a left move. And then k is our vertical move, and it's not tricky. Plus means up, minus means down. Okay, so with that said, the way I like to do these is you don't have to plot the parent, but I like to graph these as transformations of the parent function. So you might consider just putting those 4 dots. Maybe you don't have to. But that's the way I'm going to approach this. 2, 4, 6, 8, 9, 1, 2, 3. And so to come up with the graph of this, I'm going to take these 4 dots, and each one of them I'm going to slide 2 places to the right and 5 places up. And that will give me the graph of the given equation. So starting here at the origin, 2 to the right, 5 up. That one's moved. I'll just erase it. Starting here, 2 to the right, 5 up. That one's gone. Here I am at 4, 2, 2 to the right, 5 up. Takes care of that. And then do the same thing with this last one. 2 right, 5 up. And this represents the graph that we're given. And the only thing left to do is identify the domain and range. So the domain is going to be from 2 to positive infinity. The range is going to be from 5 to positive infinity. Okay, any questions about that? Pretty easy. Like I said, once you learn these transformation rules, principles, they apply to all the parents. In our next chapter, we'll throw in the cube root parent. Okay, let's take a look at what happens with this negative 2 being multiplied. I'm going to go ahead and start by using those 4 parent points again, just not saying you have to, but just for illustration. Okay, so those 4 points represent the parent, y equals square root of x. So there's really 3 things being done to the parent here. Multiplying by -2 has this effect. We call that stretch. Now it's a negative, so it's going to be stretching this way. It's going to do 2 things, really. It's going to flip over the x-axis, and then it's going to perform the stretch in a negative direction. So to do stretch, you can just think of this. Just multiply only the y-coordinate of each of these parent points by -2. Just the y, because stretch involves pulling the graph in the direction that the y-axis goes. So if I start here with this first parent point, the y-coordinate is 0, and obviously 0 times -2 is still 0. So I've already done the multiply by -2, now I'm going to do the shift. The +3 tells me to go where? Left 3, okay? And then the -1 tells me to go down 1. And so I've done all 3 of these transformations to the origin point, so I'm just going to erase it. Okay, so here I am at this parent point. That has a y-coordinate of +1, but when I multiply by -2, it makes y -2. Okay, so your first move, this factor always multiplies by the y-coordinate only. So it turns 1, 1 into 1, -2. Now you can do your shift. Left 3, down 1. Okay, this parent point is 4, 2, but the multiplying by -2 turns it into 4, -4. Okay, just the y-coordinate by -2, and then you do your shift. Left 3, down 1. And then finally, we're here at 9, 3. But multiplying by -2 makes it 9, -6. And then I do the shift. Left 3, down 1. And these 4 points will represent the graph of my answer. That's pretty bad. So please make sure that you don't make these graphs of square root functions go both ways. They never go both directions. There will be a definite end point, and then it will continue on from that point. For today, they'll be just going to the right. Okay, what's the domain? Domain? Okay, -3, positive infinity. And then the range, negative infinity to -1. Any questions so far? These are pretty easy, I guess. You want to try one with compression, or you think you get it? It's the same idea. You want to do it? Okay. You want to start with the parent? You can always start with these as reference points. And there are 3 things we're going to do to those parent points. We're going to multiply by 1/2, which is another way of saying just the y-coordinate of each of these 4 points multiplied by 1/2. Well, that doesn't change the origin. 0 times 1/2 is still 0. The +4 means to go left. Left 4, and then down 1. So my origin point has become this. Okay, here I am at 1, 1, but when I multiply by 1/2, it makes 1, 1/2. And then you do the shift. Left 4, down 1. So you can already tell. Okay, moving on to our next point. This is the point 4, 2, but when I multiply by 1/2, it makes 4, 1. Okay, so here I am at 4, 1,
and then I'm going to do the shift, left 4, and down 1. That takes care of that point. And here I am at 9, 3, but when I multiply by half, that makes 9 3/2, which is another way of saying 1 1/2. So here I am at 9 1 1/2, and then I do the left 4, down 1 shift, and you can kind of see how the multiplication by half results in compression. It took our original parent and it just flattened it out a little bit. So that is the graph, and then we'll do the domain and range. So the domain looks like all the numbers greater than or equal to -4. So we'll state it using interval notation like this. And the range will be all the numbers greater than or equal to -1. Like that. Okay, that takes care of example 2C. And then my final examples will take care of the last set of problems that you have to do. It's the block of problems 31 to 38 on page 342. So the directions say to find the inverse of the function. So this is kind of a review of yesterday's lesson. And then we'll graph the function and its inverse on the same coordinate plane. So let's review how to take this function f of x and come up with its inverse. So the first thing I'm going to do is switch places with x and y. And then I'm going to solve for y. So I subtract 1 from each side. And then I do the square root of each side. And so that represents the inverse. But when it comes to graphing, I'm only graphing part of this parabola, because notice the domain restriction. It says for this parabola, but only for x values that are greater than or equal to 0. All right, so for my inputs, I'm going to input 0, and that gives me an output of 1. I'm going to input 1, and that gives me output 2. And I'll do another one, input 2, gives me output 5. Okay, so because of the domain restriction, this is going to be the graph of f of x. Yeah, missed my points. Okay, it's only half of the parabola. So now I'm going to sketch the inverse. So the inverse would just be found by taking these 3 ordered pairs that I've plotted and switching the xy coordinates. So instead of 0, 1, which was on f of x, I'm going to plot 1, 0. And this is the point 1, 2, so I'm going to plot 2, 1. And this is the point 2, 5, so I plot 5, 2. And so this is the graph of the inverse. And so instead of saying plus minus, I'm actually only going to have, since I've only graphed half of the parabola in essence, I'm only going to be graphing the plus. So my inverse, I'm going to call this the inverse of x. Change it back to blue. Okay, so this ends up being the inverse function, which represents just half of the parabola, so that's why I left off the negative. And then we'll state the domain for the inverse just like we did, or it was given to us for the original given function f of x. So the domain here is going to be for x greater than or equal to 1. And since they gave their domain in inequality notation, we'll do the same thing when we state the domain for the inverse function. All right, so that's the way the answers for 31 through 38 will look. Let's try another one. This is actually number 38. So if you watch this, it's almost like being given a freebie. Okay, so let's first of all find the inverse. And so we'll switch places with x and y and solve for y. 3/4 y squared. I'm going to multiply both sides by 4/3. I'm going to do the square root of both sides. And the same situation is going to happen since I'm only going to be drawing half of this parabola. Then I'm not going to worry about giving the negative part of the equation representing the inverse. Normally we would say plus minus, but we're only representing half of this parabola, which would be the positive version of the inverse. And I'm going to clean this up a little bit because the square root of 4 is 2. So I can finish this off. And I'm going to call this the inverse function. All right, so let's go ahead and graph f of x. And let's see, we'll do input 0. We can do any input that is greater than or equal to 0. So input 0 gives us output 8. So I think I'm going to go do these in 2s. 2, 4, 6, 8. All right, I'll do both of them in 2s just to make it a little bit easier. So let's do input 2. 2 squared is 4. And 4 times 3/4 is 3. 3 plus 8 is 11. So input 2, 2, 4, 6, 8, 10, 11. And let's do one more. Input 4. 4 squared is 16. And 3/4 times 16 is 12. 12 plus 8 is 20. 4, 2, 4, 6, 8, 10, 12. Puts us right here. Okay, so it's just this half of the parabola. Boy, I'm not doing a good job connecting my dots here. Okay, so that is the function f of x with this domain restriction. And now we'll do the inverse. Just take these ordered pairs and switch them. So we'll plot 8, 0, 2, 4, 6, 8. We'll plot 11, 2. This is 2, 11. 6, 8, 10, 11, 2. And this was 4, 20, so we'll do 24. And the blue represents the graph of the inverse. And just like they stated the domain, we'll do the same thing. This is for x greater than or equal to 8. 2, 4, 6, 8. And you can see that what we said earlier, these two do reflect over the line y equals x. All right, and so that's the conclusion of the notes. I hope that helps prepare you for these square root functions and their inverses. If you have any questions, let me know.